Now let's factor some polynomials by grouping. So how are we going to do that? Say for example, we're given here this polynomial. This polynomial here has 4 terms. So all we have to do is divide the polynomial into 2 groups, the first half and the second half. So we can divide this polynomial as a 2x cubed minus 10x squared. Okay, we can group these 2 terms here plus 3x minus 15. And then since we already have 2 groups here, we just have to factor the GCF, the greatest common factor, out of the first half and factor the GCF out of the second half. So from the first group, the first half, the common factor here is 2x squared, so we can extract 2x squared from this one. So we are left with x minus 5 inside our parentheses, and the other half we can factor out 3. Then we're left with x minus 5. Then we have a common factor here, common binomial factor here, which is x minus 5. So we can just factor that out, x minus 5 times 2x squared plus 3. So this is our answer. To check this one, we can use the FOIL method. You can just multiply the factors, and I've already discussed this in the previous video. So let's try another example, another problem. What if we're given a polynomial that has 3 terms? Say we're given x squared plus 7x plus 12. So how are we going to group this? Oh, we can split the middle term into 2. So let's say we can write 7x as 4x plus 3x. Okay, because 4x plus 3x is just equal to 7x, and now we can group this polynomial into 2 halves. So we can group x squared and 4x together, plus, and then we can group 3x plus 12 together. And now we can factor out the common factor. So from the first group, the common factor is x. So we're left with x plus 4 here. And then the other half, common is 3. So we are left with x plus 4 here. So we have a common binomial factor, which is x plus 4. So we can factor that out and then multiply by x plus 3. So we can always, again, we can always check this by multiplying the factors using the FOIL method to check if the factors are just equal to the original polynomial.